I'm Carol Leschbaugh, faculty member of biomedical engineering at the University of South Dakota. Today we are going to begin our dive into the Python programming language. To start, we need to configure our computers with the requisite development environment. There's numerous options for developing Python programs, but for this workshop, we've chosen to use the Jupyter Notebook. Jupyter Notebook is a web-based interactive environment for developing documents. These documents can contain both code and other elements, for example, text, figures, links, and equations. The Jupyter system supports many programming languages called kernels in the Jupyter ecosystem, including Python, Java, R, and MATLAB. Out of the box, Jupyter is configured to run Python, but additional kernels can be installed. Jupyter Notebook provides the ability for users to execute Python code directly in the browser. Jupyter is widely used by scientists and researchers, but it's not really appropriate for developing large-scale applications. To configure our development environment, we need to install the Jupyter Notebook and the Python interpreter. To simplify this installation process, we will install everything we need for our development environment using Anaconda. Anaconda will install both Python and the Jupyter Notebook. We'll download the Anaconda install package from the link provided. Both Python versions 2 and 3 are available on this download page, but it's important for you to select a Python 3 version, currently 3.7, for this workshop. Once downloaded, you can execute the Anaconda install package. We are installing the individual edition of Anaconda. This installation is free and will provide the open source versions of Jupyter Notebook and Python interpreter. When you're ready, click the download button. You will be provided with a list of download options for your specific computer type. You'll probably select between Python version 3.7 64-bit graphical installer for Windows or Python version 3.7 64-bit graphical installer for Mac OS. To download the Anaconda install package, simply click on the desired option from this list. We will begin by briefly walking through the Anaconda installation process for a Windows machine. You will be presented with a screen asking if you would like to install Anaconda for just you or for all users. You want to select the Just Me option. Then click the Next button. Next, you will have the option of specifying where on your machine you would like to have Anaconda installed. You can enter the path where you would like to have it located, or you can select the default option. Then click Next. You will be asked to choose whether to add Anaconda to your path environment variable. We recommend not adding Anaconda to the path environment variable, since this can interfere with other software. Instead, you can execute Anaconda by opening the Anaconda Navigator, which we will demonstrate shortly. Next, you will be asked to choose whether to register Anaconda as your default Python. Unless you plan on installing and running multiple versions of Anaconda or multiple versions of Python, accept the default and leave this box checked. Now click Install. This screen provides a link that would allow you to install PyCharm for Anaconda. PyCharm is an IDE, an integrated development environment for Python. This platform offers tools such as a code editor and a debugger. This is the type of platform you would want to use if you were developing large-scale applications. We'll skip this option, so click Next. After successful installation, you will see the Thank you for installing Anaconda screen. If you wish to read more about Anaconda, check the boxes Anaconda Individual Edition Tutorial and learn more about Anaconda. Then click Finish. To execute Anaconda on a Windows machine, simply type Anaconda in the Windows search box found on the bottom left portion of your computer screen. A variety of different Anaconda options will pop up, and just select the Anaconda Navigator. The system will display the Anaconda Navigator screen. To execute the Jupyter Notebook, click the Launch button under the Jupyter Notebook icon on this screen. The system will open Jupyter Notebook in your default web browser at the address localhost 8888. The File tab is the default active tab. Here you will see a list of all the available folders and files, including those that you create. The Running tab will display a list of your currently running processes. If you are installing Jupyter Notebook on a Mac, there's only a few differences from the Windows installation process. Once you've downloaded the Anaconda installer, double-click on it to begin the installation. You'll be presented with a screen informing you that the installation will begin. Click Continue. The next screen provides information about the Anaconda installation process. Click Continue. The installer presents the licensing agreement for this software. Click Continue. You are asked to agree to the licensing agreement terms. Click Agree. The default Anaconda installation option is Just Me, which provides an independent installation for Anaconda that will not be shared with other users on the same system. You want to select Install for Only Me and click Continue. The default Anaconda installation location is provided. You have the option of changing the location where the software will be installed. Once you decide on a location and selecting the default is fine, click Install. Here you are notified that the installation is complete and are offered the option of installing PyCharm. PyCharm is an integrated development environment for Python that provides functionalities such as smart code completion, debugging, on-the-fly error highlighting, and rich navigation capabilities. You may want to consider this option when you're ready to create large-scale Python programs. Click Continue. An Anaconda Navigator icon will appear in your Mac Launchpad. Double-click on this icon to execute the Navigator. You are presented with the same option screen that we saw during the Windows installation. Click the Jupyter Notebook Launch button. The first task we want to perform is to create a folder in our Jupyter Notebook for this workshop. To accomplish this, click the New button in the top right corner of the screen. Select Folder option from the drop-down menu. The system will create a new folder called Untitled Folder, and it will appear in the file list. We want to provide a more meaningful name for our workshop folder. To rename the untitled folder, find it in the file list, check the box next to its name, click the Rename button at the top of the screen, enter _Python Workshop, and then click the Rename button. Now we're ready to create a Python notebook. And we want to make sure that this notebook is created in our EPSCoR Python workshop folder. So to make that folder our active folder, find the EPSCoR Python workshop folder in your file list and double click on it. Now we're ready to create our notebook. To do this, we want to click on the New button in the upper right corner of the screen and select the Python 3 option from the drop-down menu. This action will result in the system creating a new Python 3 notebook with the title Untitled, and it will be opened in a new browser tab. To provide a name for your notebook, double-click on the Untitled label at the top of the screen. A dialog box will be displayed in which you can provide the notebook name. Enter Introduction to Python Print function as the name of your first notebook. Then click the Rename button. Cells form the body of a notebook. There are two primary cell types. Code cells will contain Python code that will be executed, and their output will be displayed directly below the cell. A markdown cell contains formatted text that we'll discuss later. In this screenshot of a new notebook, the box with the green outline is a default empty code cell. The first cell in a new notebook is always a code cell. Let's test it out with the classic Hello World example. In the code cell, type print Hello World, just as you see displayed on this screen. The Python print function is used to communicate information to the user. We can print literal information using this print function. Print is followed by open and close parentheses. Inside these parentheses, you can enter your literal enclosed in a single or double quotes. For example, our literal is Hello World. This print statement is executed by clicking the Run button on the toolbar. The system will display Hello World to the user directly below the code cell. The simplest form of a print statement is the function name print, followed by open and close parentheses with nothing in between. This will result in the system outputting a blank line. In this example, we show how to print 2 lines of information to the user with a blank line separating them. So we communicate to the user, "Hello world," then a blank line, then "How are you?" You can print multiple expressions using one print statement. In this example, we show how to separate literals using a comma. So here we have the literal "Hello world" separated by a comma, then followed by the literal "How are you?" The system will output "Hello world, how are you?" all on the same line separated by a space. After the output within a print statement is displayed on the screen, a new line character is outputted. In other words, the next print statement that is executed by the system will have its output displayed at the beginning of a new line. As a programmer, you have control over how you would like to have your output formatted. For example, you may want the output of a following print statement to be displayed on the same line as the output from the previous print statement. To begin the next output on the same line as the previous one, Python provides the end equals expression that lets you specify what you want displayed at the end of the output. The end equals option is added to the end of your print statement expression preceded by a comma. In this example, we have decided that we want to output the literal name ending with a colon plus a space. The next output, Carol, is displayed on the same line following the colon plus space separator. Recall that by default, when we have literals within a print statement separated by commas, their output is displayed on the same line separated by blank spaces. So in this example, we have the literals, hello, world, how are you? When this print statement is executed, these literals are displayed on the same line separated by blank spaces. Python provides the separator expression SEP equals and then an expression in double quotes. And this allows us to control how the expressions within a print statement are separated. If we want each literal outputted on a separate line, we can use the \n, which is a non-printable character representing a new line, as our separator. So in our example, we have the literals, hello, world, how are you? And we want them separated by \n, which is a new line character. So when this print statement is executed, each literal within that print statement is displayed on a separate line. This slide provides two additional examples of the use of the separator expression. The first example, we have our literals, hello world, how are you? And we want them separated by a comma. So you can see when that print statement is executed, each of the literals is separated by a comma. The second example, we want them separated by a tab. You use \T to represent the non-printable character tab. So when we have hello world, how are you? And we want them separated \T, you can see that the output when the print statement is executed is displaying each of the literals separated by a tab. Programming comments and other text are a very important component of your Python workbook. These comments and texts are ignored by the Python interpreter when your code is executed, but they become very important because they help you to communicate to others information regarding your development. For example, when was the notebook created? How was it created? Why was it created? And who created it? So at the top of our notebook, we're going to create text that communicates to users information about our workbook. We are going to add this information at the top of our workbook using a Jupyter Notebook Markdown cell. To create a new Markdown cell, first we click the plus button in the menu toolbar, and then once the cell has been created, select Markdown to change it from code to Markdown. So once your Markdown cell is created, enter the following information. For example, the workbook name, the author, the session, the last modified, and the description. So I provided an example on this slide that shows that this workbook name is Operators and Assignment Statements. The author is Carol Lushbaugh. The session is 1. It was last modified on July 22nd, 2020. And the description is that this workbook provides an introduction to the Python print function, operators, and assignment statements. You will notice that this Markdown cell was created at the bottom of your workbook, and we want to move it to the top of the screen. To do that, select the cell, then use the up arrow button on the menu bar to move it up to the top. This screen just provides a completed example of some of the steps that we talked about during this lecture. This workshop is divided into sessions. So for example, in session 2, we have presentations, and then we have exercises. So for session 2, we have 3 presentations, one on operators, one on assignment statements, and one on import modules. And each file name indicates the amount of time it would take to play each of the presentations. Then in addition to the presentations, we have exercises. The exercises are written in a Word document, but they're also included in a Jupyter notebook. So for example, for session 2, we have exercise 1, variables and assignment statements. The extension IPYNB indicates that that's a Jupyter notebook. Those files can be imported into your Jupyter notebook, and you can work on them within that environment. To import an exercise into your Jupyter notebook, first go to your EBSCOR Python workshop folder within your Jupyter notebook. Then click the Upload button on the upper right corner of the screen. This will bring up a file dialog window where you'll be able to select the file to import. In this example, we're importing exercise 1, variables and assignment statements. We select that file and we click the Open button at the bottom of the screen. Now click the blue Upload button, and that will actually upload the exercise into your notebook, and it'll be ready to work with. Now you can begin working on the exercise within your Jupyter notebook. Notice in the session folders, there's also a solution included. You can additionally import the solution to the exercises to check your answers.